Acids, bases and salts. Introduction. You have learnt in your previous classes that the sour and bitter tastes of food are due to acids and bases respectively present in them. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar or baking soda solution? Which property did you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. Recall how we tested sour and bitter substances without tasting them. You already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the red litmus to blue. Litmus is a natural indicator. Turmeric is another such indicator. Have you noticed that a stain of curry on a white cloth becomes reddish-brown when soap, which is basic in nature, is scrubbed on it? It turns yellow again when the cloth is washed with plenty of water. You can also use synthetic indicators such as methyl orange and phenolphthalein to test for acids and bases. Have you noticed that a stain of curry on a white cloth? How do acids and bases react with metals? Take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules to it. What do you observe on the surface of zinc granules? Pass the gas through soap solution taken in a glass trough. The soap bubbles filled with the gas rise up. To check the gas contained in the bubbles, bring candle near the soap bubbles. The bubble bursts and the gas present in it catches fire with a pop sound. This shows that the gas is hydrogen. Note that the metal in the above reactions displaces hydrogen from the acids. This is seen as hydrogen gas. The metal combines with the remaining part of the acid and forms a compound called a salt. Thus, the reaction of a metal with an acid can be summarized as acid plus metal gives salt plus hydrogen gas. How do metal carbonates and metal hydrogen carbonates react with acids? Take 2 test tubes, label them as A and B. Take about 0.5 grams of sodium carbonate, that is Na2CO3, in a test tube A. Add about 2 ml of dilute HCl to the test tubes. Pass the gas produced in each case through lime water, that is calcium hydroxide solution, as shown in figure, and record your observations. What do you observe? We will observe that the lime water turns milky, showing that the gas evolved is carbon dioxide. The reactions occurring in the above are written as test tube A, Na2CO3 solid plus 2 HCl aqueous gives 2 NaCl aqueous plus H2O liquid plus CO2 gas. Test tube B, NaHCO3 solid plus HCl aqueous gives NaCl aqueous plus H2O liquid plus CO2 gas. On passing the carbon dioxide gas evolved through lime water, CaOH twice aqueous plus CO2 gas gives CaCO3 solid plus H2O liquid. On passing excess carbon dioxide, the following reaction takes place. CaCO3 solid plus H2O liquid plus CO2 gas gives CaHCO3 twice aqueous. Limestone, chalk and marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonates react with acids to give a corresponding salt, carbon dioxide and water. Thus, the reaction can be summarized as metal carbonate or metal hydrogen carbonate plus acid gives salt plus carbon dioxide plus water. Reaction of metallic oxides with acids. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? You will notice that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper-2 chloride in the reaction. The general reaction between a metal oxide and an acid can be written as metal oxide plus acid gives salt plus water. Reaction of a non-metallic oxide with base. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce a salt and water. Since this is similar to the reaction between a base and an acid, we can conclude that non-metallic oxides are acidic in nature. What do all acids and all bases have in common? We have seen that all acids have similar chemical properties. What leads to this similarity in properties? All acids generate hydrogen gas on reacting with metals, so hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic. Take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix 2 nails on a cork and place the cork in a 100 ml beaker. Connect the nails to the 2 terminals of a 6-volt battery through a bulb and a switch as shown in figure. Now pour some dilute HCl in the beaker and switch on the current. Repeat with dilute sulfuric acid. What do you observe? Repeat the experiment separately with glucose and alcohol solutions. What do you observe now? Does the bulb glow in all cases? The bulb will start glowing in the case of acids as shown, but you will observe that glucose and alcohol solutions do not conduct electricity. Glowing of the bulb indicates that there is a flow of electric current through the solution. The electric current is carried through the solution by ions. Since the cation present in acids is H+, this suggests that acids produce hydrogen ions, H+ aqueous, in solution, which are responsible for the acidic properties. What happens to an acid or a base in a water solution? Take about 1 gram solid NaCl in a clean and dry test tube and set up the apparatus as shown in figure. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? Test the gas evolved successively with dry and wet blue litmus paper. In which case does the litmus paper change color? On the basis of the above activity, what do you infer about the acidic character of dry HCl gas, HCl solution? Bring a dry blue litmus paper on the mouth of the test tube. It is observed that the litmus paper does not turn red. Now, bring a wet litmus paper on the mouth of the test tube. It is observed that it turns red. Alternatively, first pass HCl gas through water taken in a test tube and test the solution with blue litmus solution. It will turn red. If the gas is passed through benzene or toluene and test the solution with blue litmus, it will not turn red. This experiment suggests that hydrogen ions in HCl are produced in the presence of water. The separation of H plus ion from HCl molecules cannot occur in the absence of water. HCl plus H2O gives H3O plus Cl minus. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, hydrogen ions must always be shown as H plus aqueous or hydronium ion, H3O plus. H plus H2O gives H3O plus. We have seen that acids give H3O plus or H plus aqueous ion in water. Let us see what happens when a base is dissolved in water. NaOH solid, when dissolved in water, gives Na plus aqueous plus OH minus aqueous. KOH solid, when dissolved in water, gives K plus aqueous plus OH minus aqueous. MgOH twice solid, when dissolved in water, gives Mg2 plus aqueous plus 2OH minus aqueous. Bases generate hydroxide, that is OH ions, in water. Bases which are soluble in water are called alkalis. How strong are acid or base solutions? A scale for measuring hydrogen ion concentration in a solution called pH scale has been developed. The P in pH stands for potence in German, meaning power. On the pH scale, we can measure pH from 0, which is very acidic, to 14, which is very alkaline. pH should be thought of simply as a number which indicates the acidic or basic nature of a solution. Higher the hydronium ion concentration, lower is the pH value. The pH of a neutral solution is 7. Values less than 7 on the pH scale represent an acidic solution. As the pH value increases from 7 to 14, it represents an increase in OH minus ion concentration in the solution, that is, increase in the strength of alkali. Generally, paper impregnated with the universal indicator is used for measuring pH. One such paper is shown. The strength of acids and bases depends on the number of H plus ions and OH minus ions produced respectively. If we take hydrochloric acid and acetic acid of the same concentration, say 1 molar, then these produce different amounts of hydrogen ions. Acids that give rise to more H plus ions are said to be strong acids, and acids that give less H plus ions are said to be weak acids. pH in our digestive system. It is very interesting to note that our stomach produces hydrochloric acid. It helps in the digestion of food without harming the stomach. During indigestion, the stomach produces too much acid, and this causes pain and irritation. To get rid of this pain, people use bases called antacids. One such remedy must have been suggested by you at the beginning of this chapter. These antacids neutralize the excess acid. Magnesium hydroxide or milk of magnesia, a mild base, is often used for this purpose. Self-defense by animals and plants through chemical warfare. Have you ever been stung by a honeybee? Bee sting leaves an acid which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. stinging hair of nettle leaves inject methanoic acid, causing burning pain. More about salts. Chemicals from common salt. By now you have learned that the salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is the salt that you use in food. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of solid salt are also found in several parts of the world. These large crystals are often brown due to impurities. This is called rock salt. Beds of rock salt were formed when seas of bygone ages dried up. Rock salt is mined like coal. You must have heard about Mahatma Gandhi's Dandi March. Did you know that sodium chloride was such an important symbol in our struggle for freedom? Sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride, called brine, it decomposes to form sodium hydroxide. The process is called the chlor-alkali process because of the products formed, chlor for chlorine and alkali for sodium hydroxide. 2NaCl aqueous plus 2H2O liquid gives 2NaOH aqueous plus Cl2 gas plus H2 gas. Chlorine gas is given off at the anode and hydrogen gas at the cathode. Sodium hydroxide solution is formed near the cathode. The three products produced in this process are all useful. Bleaching powder. You have already come to know that chlorine is produced during the electrolysis of aqueous sodium chloride or brine. This chlorine gas is used for the manufacture of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime, that is CaOH twice. Bleaching powder is represented as CaOCl2, though the actual composition is quite complex. CaOH twice plus Cl2 gives CaOCl2 plus H2O. Baking soda. The soda commonly used in the kitchen for making tasty crispy pakoras is baking soda. Sometimes it is added for faster cooking. The chemical name of the compound is sodium hydrogen carbonate or NaHCO3. It is produced using sodium chloride as one of the raw materials. NaCl plus H2O plus CO2 plus NH3 gives NH4Cl, that is ammonium chloride, plus NaHCO3, that is sodium hydrogen carbonate. The following reaction takes place when it is heated during cooking. 2NaHCO3, that is sodium hydrogen carbonate, on heating gives Na2CO3, that is sodium carbonate, plus H2O plus CO2. Sodium hydrogen carbonate has got various uses in the household. Washing soda. Another chemical that can be obtained from sodium chloride is Na2CO3 10H2O or washing soda. You have seen above that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also a basic salt. Na2CO3, that is sodium carbonate, plus 10H2O gives Na2CO3 10H2O. Are the crystals of salts really dry? Heat a few crystals of copper sulfate in a dry boiling tube. What is the color of the copper sulfate after heating? Do you notice water droplets in the boiling tube? Where have these come from? Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. What do you observe? Is the blue color of copper sulfate restored? Copper sulfate crystals, which seem to be dry, contain water of crystallization. When we heat the crystals, this water is removed and the salt turns white. If you moisten the crystals again with water, you will find that blue color of the crystals reappear. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. 5 water molecules are present in one formula unit of copper sulfate. Chemical formula for hydrated copper sulfate is CuSO4 5H2O.